In this video, we're going to simulate two computers talking to each other. You're going to have a client and you're going to have a server. This is called computer networking, and one of the main ways that we solve computer networking is with sockets. And what we're going to talk about today is what are called network sockets. You can think of a network socket as something that is used to connect these two computers together so that they can talk and they can transmit information to each other. So basically the socket runs from everything from the computers saying, hey, I'm willing to listen to something, to, hey, I want to send this computer another message. And how it addresses the computer and what all it sends, that's the beauty of computer networking. Think about in human history before there was language and we could communicate well amongst each other. There really wasn't much that we could do to really build up civilization. But then shortly after we figured out how to communicate, all of a sudden the possibilities are endless. In fact, that's exactly what the internet is doing. It's connecting all of these devices together. To introduce the concepts of networking, we're going to have these two devices here that are going to talk amongst each other. One of them is going to act like a server and one of them is going to act like a client. So a server could be an example like a web address that you type into a browser, and then you would be the client trying to initiate a connection to that server. So now that you know what networking is and what the basic concept of a socket does within networking, let's go ahead and write some code that uses sockets. All right, so to get started, what I'm going to do here is I'm going to have a single application that's responsible for running both a server and a client. So what my main class needs to do is it needs to take some system input and then it needs to determine whether it wants to create that server or client class and then actually execute the networking code. So to do that, what I'm going to do is I'm going to read in some user input to determine which one I want to create. And then we're going to go ahead and either instantiate a server or a client. All right, so what this code is doing is first, it creates a scanner over system.in using try with resources, meaning that at the end of the try block, we are going to close that scanner. And then what we're doing here is we're prompting the user for a yes or a no. If we do get the Y character here, then we're going to start a server, which currently has no implementation in here. Otherwise, we're going to create a client later. So now we need to fill in the start method of this server here. So the first thing we want to do in here is we want to create what's called a server socket, where a server socket is something that lives only on the server, which is listening for connection attempts from these various clients over here. So when a client initiates a connection, the server says, okay, I've got a server socket. Now I'm going to create a bidirectional connection between the two of us. So to do that, I'm going to go ahead and again use the try with resources, and I'm just going to say server socket equals new server socket. And then it's going to be over the port number. And then this does throw an IO exception. And then I'm just going to be lazy and I'm going to wrap this in a runtime exception like this. So the reason that our server socket here needs to have this port number is because when I'm a server over here, I might be running one or I might be running 1,000 different applications that this server is going to be able to handle. So when I'm establishing a server socket for this particular application, I need to tell the server which of my many ports I'm going to assign in order to receive connections. I like to think of a port as essentially a sub address when you know the host that you're trying to talk to. So within the concept of snail mail, let's say I want to send a letter to a standalone address. I can go ahead and I just do that directly and the mail person knows exactly where that is. Now let's say that I want to send it to a particular unit number within an apartment complex. I have to give the address of the apartment complex, then I have to give the unit number. So you can think of the port here as kind of similar to a unit number within something like an apartment complex where it all shares the same address, where the IP address is going to be that shared address, and then the port number will be the unit number. That's just an analogy I use when I try to explain the difference between the address versus the port number. And the address here is implied as localhost, meaning that I'm going to run this server on the same system that I'm running the code on right here. And it's going to listen on that interface and this particular port number. So now that I have a connection, I want to get a socket out of it. So I'm going to call this socket. And what this is going to be is this is going to be server socket.accept. The accept method is going to block, meaning that it's going to wait for a client to come in and create a connection. And then you get the socket object back, which indicates the socket that is now going to be used to communicate bidirectionally between our server and our client. So one other really quick thing I want to mention is when I create a socket within Java, what I'm doing is I'm creating a stream socket by default. You can create what's called a DatagramSocket, which is used for UDP, or the user datagram protocol. But the default behavior is to create a stream socket, which matches the TCP, the transmission control protocol. I don't really want to deep dive the difference between UDP and TCP in this video, but just note that within the OSI model, the layer 4, we're talking about TCP sockets here. We're not talking about UDP sockets. So now that we have this socket object here, that means that when this line of code is done, we have an established connection with a client. So this socket is going to have information such as the IP of the client that we're talking to, the port number that it is sending information on, and the message, or what we're going to call the payload data, that would be inside of the socket at any given time. Basically how this is going to work is that we're going to read the client's input stream to us. So as the client sends information over out on that stream socket, we're going to get information into an input stream, and then we're going to go ahead and print it out within the server. Just to make it clear that this socket is a client socket, I'm going to call it client here, and let's go ahead and write the rest of that code quick. All right, I think that should do it. So talk through this a little bit. So this is now the socket object that represents our client connection. We're getting the IP address via this get inet address and get host address method here. Basically, when we're talking about host address, we're talking about the IP address. Here we're getting the port number of the client, and then here's where it gets a little more interesting. So we're getting the input stream of the client. We're reading the input stream like so. The input stream reader wrapper you can think of as a thing to be able to convert an input stream of bytes into an input stream of strings. And then we're going to wrap it in a buffered reader because buffered readers are the most efficient way that you can read segmented data. Technically, you don't really need the buffered reader if you're talking about not all that much data, but I'm just kind of used to using buffered reader in this situation, so I've got it here. So this is now our input stream. And then we're doing this for loop here. Some people would rewrite this as a while loop. I personally prefer it as a for loop because it's a little more succinct. We have an input line here that we're basically making sure isn't null, and then we have no condition to add on after that. So we're gonna keep going in this for loop until we have a null read line. And then we use a string template here to print out the client's IP address, their port number, and then the message that the client sent us. Cool. And it does look like I have a little bit of a typo here. All right, let's go ahead and run it and see what it's doing. All right, so yes, this is a server, so we're gonna hit the Y character. And now we can see that we're not doing anything. Okay, so I might wanna add in a print indicating that we're waiting for a client. I'll go ahead and do that quick. We'll stop this and change that. So up here, let's say something like waiting for clients. And we'll try running it again. Yes, we are a server. And now we're waiting for clients. So what's going on right here is that the server socket is up and running and it's waiting for a client to attempt to connect to it. So we have to create now the client class over here to attempt a connection to our server socket so that we can create that bidirectional socket so that they can talk. All right, so let's do that next. So kind of like before, we're gonna make a client and we're gonna start it with the port number for now. And then let's make a myClient class. And then it will have a start method with a port number. So the first part of this code will look very similar to the server code. What we need to do is instead of creating a server socket, we're going to create a just plain old socket. I keep typing soccer. I don't know why I'm doing that. So I'm going to give a host name of localhost, and then it's going to bind on that port number, and I have to import socket here. So like I was mentioning earlier, when I create a socket, this is going to be a TCP socket. I could make this a DatagramSocket if I wanted to, and that would be using UDP. Instead today, what I'm going to show is using TCP with just regular old sockets. And similar to before, this can throw an IO exception. So let's do that. And then let's wrap this in a runtime exception. So now that the socket has been created within this try with resources block, what that means is we have created the socket within the operating system, but we haven't actually sent anything yet. So the connection isn't really established, but we're ready to start sending data. So let's take a look at that. So I can indicate to the user socket created. So I'm going to do something similar over here to what I did with the server. And that is over here, we're basically going to keep sending data to the server until we don't have any more data to send. And the server is going to keep receiving it until there is nothing more to receive. So how do we do this over here? Let's do user input. So let's say for string user input equals, okay, we're going to have to create a scanner, and I don't want it to be empty. So I'm going to say something like that. So when it's not empty, and then I need to pass in the scanner here. So let's do that. I don't want to create the same scanner as I already had in the main method, because I'd be creating a scanner over the same system.in, and generally speaking, you really want to avoid doing that. So I'm going to go ahead and pass in scanner into my client, like so. And then now scanner is going to go into the client. So what I need to do now is over here, when I read something out of system.in, I need to convert that into a socket output that gets sent over to the server, who can then read it. So I need to get the socket's output stream, and then I need to essentially pipe the scanner's data into the output stream. The easiest way to do that is to get the output stream, wrap it in a print writer, and then do a print line passing in the string that we want with the print writer, which will then redirect the output into the socket. So let's do that here within the try with resources, because print writers also implement auto closable. So I'm going to say writer, and this will be a print writer, and we need to do that over the socket's output stream. And then the other thing I want to do with this print writer is I want it to always flush automatically for me. I don't want to have to call flush all the time. So I'm going to say true there, where that true parameter indicates that it is auto flushing. So the flushing is important because when a print writer flushes, that is what triggers the print writer to actually do the writing operation, and then it'll go into the socket's output stream and get sent out over the network. So now this line of code in here is simply writer.println, because we want to indicate a new line character to indicate the auto flushing. And then I want to print out user input. So what this is going to do is anytime I type something onto the terminal and hit enter, then the print writer is going to write to the output stream of the socket, and it's going to send it over the network to the server, who is now waiting for a response on the socket's input stream, and then it's going to print the data out on the server. So if you want to run a single program multiple times within IntelliJ like this, you want to do run, edit configurations, and then you would add an application entry within here, where the important thing is this bottom element right here, allow multiple instances. This is what allows you to run multiple instances of the same program concurrently within the tool. So now that we've done that, I'm going to go ahead and cancel out of this version, and I'm going to say yes, my server's running. And now my server's waiting for clients. So I'm going to run another instance of my program, and I'm going to put it over here. So now my server is still waiting for clients here, and now I'm going to be a client. Okay, so now I have a socket created, and my server, it claims it's still waiting for clients. I should probably indicate another print when I get a client connected. But let's go ahead and try this. Aha, there we go. So isn't that cool? Our client wrote this code. We hit the new line character, and then on 127.0.0.1, which is the same address as the local host, meaning that I am hosting this all on my internal machine, and I'm not talking technically to different addresses, but it would all work the same anyway. This port number here is the port number that I am addressing the server with the bidirectional socket that was created, and the server is echoing what it received from the client. Awesome. So there are two things I want to change with this code. The first thing is I want my server to indicate to me, the user, when a client connection is created. The second thing I want to do is I want my server to regurgitate the message it received back to the client and I want it to reverse the string just to show that I'm manipulating the data here. So let's go ahead and make those changes. Both of those are going to be in server initially. So within the server, when I accept, I'm just going to move this down for here, and I'm going to say client connected. So now I'm not going to get a print when I have the server socket available, but I'm going to get a print whenever I have made a client connection. And note that I'm only making one client connection here. That's really important, and I'll get to that more later. So now what I need to do is I'm reading out the client's input stream, meaning when I get a message over here, I'm reading in the input data that came from here. I now need to write data to that same output stream so that the client can receive it. So I need access to both the input stream and now also the output stream. So the first thing here is I actually made a mistake earlier. I really should be wrapping this in a try with resources as well. And the reason for that is because the client input stream is a stream, and when you no longer need access to a stream, you should close it. The try with resources will automatically do that for you, so it's good practice to do that. I want to move this code in here. So now in addition to the input stream, I want access to the output stream. I'm just going to say client.get output stream. And then you guessed it, similar to what we did in the client, we are going to wrap this in a print writer and make it auto flushing. Print writer. Yes, flush it automatically, please. And I need to add a semicolon here. And there we go. Okay. So now when our server receives a message over here, I want to take that, I want to reverse it, and I want to send it back. So to do that, I'm going to do output.println, and then I'm going to create a new string builder with input line, and I'm going to reverse it. And this reverse method does return a string builder, but the nifty thing here is that println accepts an object argument, which is going to call toString on, which basically makes us not have to call toString explicitly within this call right here. So this is all we should have to do on the server side in order to take the input data that we received, reverse it, and send it out to the output stream. Now over here on the client, we need to take that input stream from the server, because so far all we're doing right now is we're outputting data to the server. So we also need to be able to receive input data. So let's go to the client and let's do that next. So similar to how the reader code works in the server, we're going to do the same concept in the client. So within our try with resources here, we're going to say that the reader equals socket.getInputStream. And then in the client here, after we write out the data, let's go ahead and print out the result in a string template, like so. So we'll say response, and then we'll say reader.readLine. Think it'll work? Let's see. First, we'll set up our server, then we'll run it again, then we'll have our client. So now we have the client connected and our socket was created. Excellent. Hello. So we can see here that our server received data on this port of hello from our client. And then what it's not indicating, I could go ahead and add in a print indicating that the server is going to now send something to the client. But you can see that the server is sending the client message in reverse. Let's go ahead and do a few more examples just to make sure that it's working. Is this working? I think it is. Let's do a palindrome. 2002. Awesome. So these are some of the fundamental concepts when it comes to socket programming within Java, where at least with this API, you have a server socket that blocks and waits for a response for a client to initiate a connection. And then now either the client or the server can now send messages to each other and they can do something with the data. The underlying protocol that a regular socket is using within Java is going to be TCP, but there is the option of DatagramSockets if you want to do something like the user datagram protocol. So the example we just went through where you had a server and a client talking to each other, that's great. The problem though is that oftentimes servers are called servers because they're intended to handle many, many clients. It would be really annoying if you wanted to do a Google search and Google just crashed because somebody else was doing another search, right? Yeah, that doesn't work. Your server needs to be able to handle many, many different clients. So there are multiple ways to do that, but what I'm going to show today is using a multi-threaded model where you have a virtual thread handle each client. Let's go ahead and write that code next. So just to get at some of those existing limitations, let's demonstrate that. If I run the server here and I'm waiting for client connections, and I have a client here first, I can see that I have a client connected. The client has a socket created. Now I'm going to run a second client, which happens all the time. And I'm going to go ahead and have to turn my video off here to really show this. So it's not a server. You'll notice that I had created the socket here within the client, but the server didn't indicate anything. Does this work? No, it does not. Does this work? Yes, it does. Interesting. So why isn't this working? Well, what it comes down to is in the server code, all we do is we request one accept method response. When that accept method returns, there's no looping within the server code. It just says, okay, I got my client connection, now I'm gonna move on. So what we need to do is we need to refactor our server in order to handle multiple incoming clients. Let's go ahead and do that next. So the crux of the problem right now is that this server socket accept only gets called once. Let's go ahead and fix that. So we're gonna make an executor, which equals executors dot new virtual thread per task executor. And then now I'm gonna wrap this in the good old while true, which should be raising some alarm flags for you, but we'll get to that here in a second. I'll go ahead and move all this code into the while true. And now the last crucial thing we have to do is our executor needs to now dispatch a virtual thread whenever we're ready to do so. And we're going to do that after we accept a client connection. So I'm going to do executor.submit a runnable. And the runnable is going to be all of this code. You will see we have a few errors here now, and that's because we're within the context of a Lambda expression and we no longer have a catch block within the context of the code that we're guaranteed to run within the runnable that's going to catch the checked exception. So now we have to also add a similar exception clause right here. And that looks much better. Okay, so now what this code is doing here is we create our server socket over here. And now the server socket is going to be waiting for client connections. And then we have an executor ready to dispatch virtual threads whenever we get a client. This line of code then accepts the client connections. And then as soon as we're ready to process those client connections, we have a virtual thread that gets kicked off in order to do that. And that goes within this runnable right here. And this will infinitely loop where the server is here waiting for additional clients to connect. So think about that for a second. Do I really want to infinitely loop for a server? Yeah, probably. How do I know when to really shut down the server? Wouldn't you want it always to be running? I don't know about you, but if I'm a client and I'm trying to create a connection to something like Google and Google is non-responsive, that's gonna really irk me. I'm gonna want those servers working all the time. I want the code always running. So a while true might actually make sense here because I want the server always ready to accept client connections. So let's go ahead and try out the code and see if it behaves differently this time. So yes, this is the server this time. And I need to acknowledge that. This is our first client. And then now we're gonna have our second client. And I will hide my camera again. Is this a server? No. Is this a server? No. We can see that both of our clients have connected. Hello. What's up? Sweet. So we got responses from both clients here. So these are both the same address because they're both running on my PC, which is the local host here, but we're looking at different port numbers. So these are indicative of different clients. And we can see that the server does send responses to each of these clients separately. So looks like it's doing its job. Pretty cool, right? We essentially just created a server application that waits for client connections, receives a connection request, establishes a connection, and then responds to clients by inverting the text that they sent them. And it can handle end clients depending on what the operating system can handle as far as virtual threads, which if you haven't already, check out my video on virtual threads. Typically an operating system can handle thousands, if not millions of virtual threads. So I think our application is pretty scalable within the current example. Now, one other thing I want to mention really quickly is that in JDK 1.4, they did make a pretty interesting API update. One of the problems with this API is that there's a lot of blocking going on. Blocking is kind of a pain within code, and it can cause a lot of problems if you're not handling the blocking scenarios correctly. The Java NIO, or New Input Output package, added a lot of convenience methods that added a different way to do socket programming that doesn't involve multiple threads, but can still talk to multiple clients. You have this concept of channels and selectors, where these channels and selectors essentially dictate which of the client connections we're going to service within a single thread at any given time. So each client connection needs to have a buffer, because if I'm servicing connections 73 and 74, and then connection 43 starts filling up because I'm taking a while on the single thread to service 73 and 74, I need to have some sort of buffer so that I don't overflow the connection while I'm processing others. So you have some buffer logic, you have some selector logic, and you have this concept of channels. All in all, it's a pretty good concept. The only reason I'm not showcasing it here today is because with virtual threads in JDK 21 and with modern CPUs being able to context switch across threads so efficiently, I don't really see as much of a use for the prior way of handling multiple clients that didn't involve heavy OS threads. But if anyone's interested in knowing more about that API, let me know in the comments and I can do a video on it. And that was an overview of socket programming within Java. If you found this video helpful, or if you learned something new, please just smash that like button. I'd really appreciate it. Thank you for watching. I hope you have a good rest of your day, and I hope to see you next time. Take care.